Welcome to our deep dive, and today we're tackling a really, really interesting document, a draft programmatic environmental impact statement from NASA.
PEIs. Yep.
Yeah, for the Mars sample return mission.
Huge.
It's a pretty dense read, I have to say, but don't worry, we're gonna, break it down and pull out all the juicy bits for you.
Right. Yeah. It's not exactly beach reading material,
Yeah.
but these PEIs documents, they're, super important.
Mm-hmm.
They analyze the environmental impacts of these, really big projects. And in this case, we're talking about bringing Martian samples, back to Earth, which is, well, it's a big deal.
It is a big deal, and it's not just, a theoretical thing anymore. This document really gives us a look into how NASA's actually thinking about pulling this off, while also making sure our planet's safe, of course.
Oh, of course, yeah.
So as we start digging into this plan, what jumps out at you?
Well, I mean, just the sheer scale and complexity of it all is just, wow. I mean, we're talking about a multi-stage operation here, and it all starts, with the Perseverance rover, which, as we speak, is, out there on Mars doing its thing.
It's amazing, isn't it? Perseverance is just out there collecting bits of another planet, and it's not alone, right?
No, absolutely not. NASA's teamed up with the European Space Agency.
Wow!
For this huge scientific effort.
I love that. It's a real global team effort.
Yeah.
So, okay, Perseverance has got its collection of samples. What happens next? We can't just, slap a return address label on them, right?
No, it's a little more complicated than that. So another spacecraft is going to land on Mars to pick up the samples from Perseverance.
Okay.
And then it launches them into orbit around Mars, where another spacecraft, a third one, catches them and sends them on their way back to Earth.
It's like a relay race across millions of miles.
Across the solar system.
Amazing. And when those samples finally make it back home, where are they touching down?
Well, the planned landing site is the Utah Test and Training Range, the UTTR. Big, remote area.
Okay.
Perfect for a controlled landing. And they're really specific about where they want to land, too. The document mentions Type 45 playas.
Type 45 what now?
Playas, P-L-A-Y-A-S. It's this specific soil type, known for being soft, sandy, and clay-like. All about making sure those precious samples have a nice, gentle landing.
Soft landing on Earth after a, however many million-mile journey from Mars.
Exactly.
So it lands safely, hopefully. What then? Do they immediately rush them off to a super secret lab?
Not right away. First they go into this special container.
Yeah.
A vault, they call it. Environmentally isolated, biocontained, the works.
Okay, now this sounds interesting. Tell me more about this vault. It sounds like something out of a heist movie.
It kind of does. But the reason for it is, twofold.
Okay.
First, they got to protect Earth's biosphere
Right.
from any potential Martian contaminants,
Yep.
even if the risk is super low. And second, they got to keep those samples, pristine. No contamination from Earth stuff. Make sure they're ready for, all the science.
That level of precaution, I mean, it's mind-blowing, isn't it? I mean, they're taking this incredibly seriously. What kind of, facility are we talking about here for this level of containment?
Well, they even mentioned it might be, get this, a BSL 4-rated trailer, like the kind they use for transporting, super dangerous infectious materials.
Oh, that's intense. So they've got this super high-tech vault. They're transporting these precious Martian samples. Where does it go next?
The final stop. The sample receiving facility, or the SRS.
The SRF.
Yeah, the SRF. That's where, all the analysis, the processing, the curating, all that happens. The document actually talks about a few different options for this SRF.
Okay.
They could build a brand new one, maybe at a NASA location, like, Johnson Space Center.
Right.
Or modify an existing one. They're even thinking about places that aren't, government run, like maybe even a university.
Oh, wow. Can you imagine going to school where they have Martian samples?
Right. The research possibilities would be just incredible.
But okay, before we get too carried away, let's talk about the big question.
Yeah.
Sterilization. These samples, I mean, are they going to sterilize them? That's got to be a top priority.
Oh, absolutely. And the document really dives into the debate about it. I mean, some scientists say, hey, got to sterilize, got to eliminate any risk, no matter how small.
Right.
But others, they're worried that sterilization could actually damage the scientific data they're trying to get.
So it's like a delicate balancing act, isn't it?
Yeah.
Safety versus, the scientific integrity of the whole thing. So how's NASA dealing with this conundrum?
Well, the PI says NASA and the ESA are, really carefully looking at all sorts of sterilization techniques.
Mhm.
And they're even considering, maybe just sterilizing parts of the samples,
Oh, interesting.
leaving some untouched, for analysis. They're really trying to, figure out the best approach here.
They're trying to find that sweet spot,
Yeah.
a perfect balance. What blows my mind is that they're even considering techniques that haven't even been invented yet. I mean, this document is like a peek into the future of science, but let's, come back to Earth for a moment, literally. What about the environmental impact of all this? I mean, that's got to be a major concern.
Oh, absolutely. And a huge part of the PEI is dedicated to, analyzing those potential impacts from launch to landing and everything in between.
Okay, lay it on me. What are some of the big things they're worried about?
Well, first of all, the impact on the UTTR itself, that landing site. Yeah, it's pretty barren.
Yeah.
So they're not expecting a huge ecological disruption, but they're not stopping there. They're also looking at, the risks from hazardous materials
Yeah.
and the waste generated by the whole mission.
So like, rocket fuel and Martian goo and
Yeah, well, document doesn't get into specifics just yet, but they do mention things like, flammable liquids, corrosive substances, maybe even stuff used for sterilization.
right.
Think about it, bringing those samples back involves like launches, landings, transport, handling, a whole chain of events. And every step, well, it can generate waste, right?
Yeah.
Stuff that needs to be managed responsibly.
It's like planning an interplanetary move.
Exactly.
And you got to think about packing and transporting and unpacking and, being mindful of where you are and the environment.
It's a huge logistical challenge.
Yeah. Are they concerned about, like air pollution, noise pollution from all this activity?
For sure. Those are definitely on their radar. They specifically mention air emissions from, the launches, landings, and even the operation of the sample receiving facility. And they're looking into ways to minimize those, using cleaner fuels and all sorts of fancy emission control technology.
It's pretty amazing how much thought they're putting into, every little thing, even noise pollution, which seems, well, a little less important compared to, maybe bringing back Martian life.
Oh, yeah. But noise pollution can be a big deal, actually, especially in a fragile ecosystem.
Yeah.
And, the UTTR, they already use it for military stuff. So they're trying to figure out what that combined impact might be on the wildlife and the people who live nearby. And
Makes sense. So it's not just about the samples themselves. It's about the whole picture, right?
Yeah,
The, the cumulative effect of all this activity. And what about water? I mean, it's the desert.
Yeah.
They're going to need a lot of water for all this, right?
Good point. And the document actually emphasizes water conservation. They're analyzing like all the water needs of the mission, from landing and recovery to running that sample receiving facility.
Right.
And they're looking into using existing water sources at the UTTR, implementing conservation measures, figuring out ways to recycle water. They really want to minimize their impact on that local water supply.
Wow. It's really impressive how much planning goes into, every aspect of this. They're really trying to anticipate any potential environmental impact, no matter how small. And there was one thing in the document, one potential challenge that really caught my eye. It said there's a chance of, encountering unexploded ordnance at the landing site.
Oh, right.
I mean, it's a former military test ground, so I guess it makes sense. But still, unexploded bombs, that's a little, unsettling.
It's definitely a unique challenge. But the document does say, safety is a top priority. They'll have a UXO technician on site
Okay.
during all the operations, to make sure everything is safe.
So they'll be, carefully scanning for any potential hazards.
Exactly.
Okay, that makes me feel a little better. So we've talked about, the plan for getting the samples, the amazing measures they're taking to contain them and sterilize them, the landing site, even potential hazards like unexploded bombs. Bringing back Martian samples, it's no walk in the park, is it?
No, it's not.
But let's not forget the why of it all. What are the big potential benefits that make all this effort, all this risk worth it?
Well, that's where things get really exciting. We're talking about potentially, unlocking secrets about Mars's history, its geology, its atmosphere, maybe even evidence of past life.
Whoa.
Think about it. we could be holding clues to the origins of life itself.
That's incredible. I mean, that would be huge. That would rewrite, well, everything we know about the universe.
Absolutely.
We'll have to dive deeper into that, though. Those potential breakthroughs after a quick break. Don't go anywhere.
I mean, these samples, Rick, they could hold like answers to questions we haven't even thought to ask yet. It's like having a time machine, taking us back billions of years.
It's incredible to think that we might, be rewriting textbooks.
Yeah.
And changing everything we thought we knew about, well, everything. But let's go back to the PEIs for a second.
Mm-hmm.
I remember you mentioned that it talked about like different ways to sterilize the samples. Can you break those down for us a little bit?
Sure. So they're looking at a few options. Each one has its own, pluses and minuses. One method is dry heat sterilization. Basically, you're baking the samples.
Baking them.
Yeah, at super high temperatures.
So like a cosmic oven, but wouldn't that like damage the samples?
Yeah, that's the worry. It's good at, killing microbes, but it can also change the chemistry of the samples. So that's why they're also considering gamma radiation.
Gamma radiation?
Using high energy rays to, zap any potential hitchhikers.
Okay, that sounds a little more high tech than baking a rock. Is it safer for the samples though?
Generally, yeah. It's considered less damaging than the heat.
Yeah.
But it's not, perfect. The document explains that each technique has its own limitations. So NASA and the ESA, they're really weighing things carefully here, trying to figure out the trade-offs, right?
It's a tough choice. I mean, you want to make sure it's safe, but you don't want to ruin the science either. The stakes are pretty high. But
right.
What I find so fascinating is that they're open to new sterilization techniques, ones that haven't even been invented yet.
Right. Who knows what the future holds?
Exactly. That's what makes this so exciting. So let's shift gears a bit. Let's talk about the sample receiving facility, the SRF, where all the science magic is going to happen. What are some of the key features of this high-tech lab?
Well, the SRF, it's going to be like a fortress of science.
Yeah.
Think multiple layers of containment, air filtration that can trap like the tiniest particles. Researchers in, special suits, gloves, the whole 9 yards.
Wow. That sounds more like a scene from a sci-fi movie than a lab. I mean, are they also worried about like contamination from, stuff on Earth?
Oh, absolutely. They're going to be following like biosafety level 4 protocols.
Yeah.
The highest level, like for handling deadly pathogens.
Right.
But in this case, it's about protecting the Martian samples from us, from Earth microbes, to make sure the research is clean.
It's amazing. I'm picturing like scientists in hazmat suits looking through microscopes at these alien rocks. What kind of equipment will they use to, unlock the secrets of these samples?
Oh, they're going to have the best of the best. Electron microscopes, spectrometers, all sorts of analytical tools. We're talking like atomic level analysis here.
So they can figure out like what it's made of, what minerals are there, if there are any, organic molecules, the building blocks of life, and maybe even like fossilized microbes.
Exactly. And think about it. The PEIs makes it clear. These samples, they could be studied for like decades.
Wow.
Using techniques we haven't even dreamed up yet.
Yeah.
I mean, the potential for big discoveries, it's just huge.
That's incredible. We're talking about a mission that could, have implications far beyond our lifetime. Now, we talked about the location of the SRF a bit earlier. Can you remind us what options they're looking at?
Sure. So they could build a whole new facility dedicated just to this. Maybe at a NASA center, like Johnson Space Center.
Yeah.
Or they could modify an existing facility.
Right.
And they're even open to, partnering with non-government places.
Yeah.
Like universities.
Right. A university with a Martian sample lab, that'd be pretty cool. But, let's be realistic for a minute. This whole thing, it can't be cheap. Building this lab, equipping it, hiring all the scientists, it's going to be a huge expense. Does the PEI say anything about, the cost of all this?
Well, it doesn't give like specific numbers.
Yeah.
But yeah, it acknowledges this is going to be a big investment.
Mm-hmm.
But they also say, hey, look at the potential return on that investment.
Yeah.
It's not just about the science,
Yeah.
right? It's about, advancements in technology. It's about inspiring future generations.
So they're saying the benefits outweigh the costs.
Yeah.
That what we learn, the tech we develop, the people we inspire, it'll all be worth it.
Exactly. It's a bold move, no doubt. But the potential payoffs, they're huge. I mean, we could be talking about revolutionizing our understanding of the universe,
Right.
and our place in it.
Wow. It's like investing in a venture that could, change the world. And speaking of investments, what about the long-term vision for this SRF? Will it always be, just for Martian samples? Or do they see it like evolving?
That's an interesting question. And the PS does kind of hint that it could become like a center for studying all kinds of extraterrestrial stuff. I mean, we're already sending missions to asteroids, icy moons. Who knows what else we might bring back, in the future.
A multi-world sample library. That's an incredible shot. It would be like a testament to our curiosity, our drive to, explore the unknown.
Right. And think about it. It would be a hub for global collaboration. Scientists from all over the world working together to, unlock the secrets of the universe.
That's amazing. But okay, let's bring it back to, the challenges here and now. We talked about the unexploded bombs. What other, surprises might they run into during this mission?
Well, space exploration, it's inherently unpredictable. I mean, you can plan all you want, but there's always the chance of, glitches, weird weather, maybe even something unexpected with the samples themselves.
So they need to be like adaptable, ready for anything. Like, a Martian dust storm or discovering the samples are like super fragile.
Exactly. The document mentions they're developing backup plans for like all sorts of scenarios, off-nominal landings, issues with handling the samples. They're being very cautious, but also, flexible.
It's like planning a road trip across, some uncharted wilderness.
Yeah.
You've got your map, your compass, but you also got to be ready for detours and, maybe running into a wild animal or two.
Speaking of encounters, let's talk about this break the chain concept. The document mentions it a lot. Can you explain like why it's so important for, protecting both Earth and the samples?
Right. So break the chain, it's all about preventing back contamination. Making sure nothing from Mars, whether it's like microbes or dust, accidentally hitches a ride back to Earth. It involves like all these protocols, barriers, no uncontained Martian material allowed.
So it's like a multi-layered shield.
Exactly. Minimize the risk, maximize the science. That's a great way to put it. It really shows how carefully they're thinking about this. It's not just about the breakthroughs, it's about the long-term consequences of, bringing a piece of another planet to Earth.
It's a huge responsibility. And they know it. I mean, this mission, it's bigger than just science, right? It's about, understanding our place in the universe.
Exactly. It's a journey of discovery. And speaking of discovery, let's talk about those potential scientific breakthroughs we keep hinting at.
Right.
What could we learn once these samples are back on Earth?
The possibilities are just mind-blowing. We could learn about the geological history of Mars, how its atmosphere formed, maybe even find, proof of past life or even present life. Each sample, it's like a time capsule telling us the story of another world.
It's like the greatest scientific detective story ever.
It is.
And the best part, the story's just beginning. I mean, these samples could fuel research for decades. We can make discoveries we haven't even imagined yet.
Imagine, figuring out Mars's ancient climate, understanding how its landscape was formed, maybe even finding evidence of, like, ancient oceans or volcanoes.
It's like putting together a giant puzzle.
It is.
And each sample is a piece. And those pieces, they might just tell us, if there ever was, or maybe even still is, life on Mars.
That's the million-dollar question, right?
Yeah.
And this mission, it brings us one step closer to answering it.
It's a journey of exploration, of discovery, and maybe even of revelation. As we wait for those samples to get here, let's just take a moment to appreciate, the incredible human ingenuity that makes this whole thing possible.
Right. It's a testament to collaboration, dedication, and just our endless curiosity to explore, to learn, to understand.
Absolutely. Well, folks, that's a wrap for this episode of our deep dive. We've covered a lot from, how they're going to collect the samples, to how they're going to keep them safe, to, the amazing things we might learn from them.
Been a real pleasure diving into this with you.
And to you, our listener, keep exploring. Check out the full PEI's document. It's publicly available. It's a fascinating read. Until next time, happy exploring.
Wow. Thinking back on everything we've covered about this Mars sample return mission, it's just incredible. Every single step from Perseverance grabbing those samples to, them being analyzed in that super high-tech lab, every detail, it's just mind-blowing.
It is. I mean, this mission, it's a real turning point in our exploration of, space. It could tell us so much about the history of Mars, how planets evolve, maybe even, how life itself began.
Okay, so we've talked a lot about, protecting Earth from anything, nasty that might be in those samples. But what about protecting the samples themselves? Once they're here on Earth, how do we make sure they stay, pure, untouched by our atmosphere, our microbes, all that.
Right, that's where the sample receiving facility, that SRF, comes in. The document, it really gets into the nitty-gritty of how they're going to make that SRF, like a protective bubble, a shield against, any Earth contamination. So, like, they're creating a little Mars right here on Earth. What would it be like, inside this Martian bubble?
Think of a lab where, the air is constantly being scrubbed clean, every surface sterilized. The researchers, they're in, like, special suits, gloves, almost like, astronauts on an alien planet.
Wow, that's an amazing image, like something straight out of a, sci-fi movie. So, in this super clean, super secure environment, what kind of research are they going to do?
Well, the document says they'll have all the latest tech. I mean, instruments that can analyze those Martian samples down to the tiniest atom, electron microscopes, spectrometers, the works.
So they can figure out exactly what the samples are made of, find minerals, those organic molecules, the building blocks of life, maybe even fossilized Martians.
Exactly. And the possibilities, they're endless. The SRF, it's designed to handle all kinds of research from, basic geology to the search for, well, signs of life.
It's hard to wrap your head around all the things we might discover. We could learn about Mars's climate, its volcanoes, if there was ever water, maybe even find proof that we're not alone in the universe.
And the PEIS, it really drives this point home. Those samples, they could be studied for, well, for a very long time. Decades, centuries even. They could be using, technology that doesn't even exist yet. It's like a time capsule, a scientific legacy for future generations.
That's incredible. It's like planting a seed that could grow into, a whole forest of knowledge about Mars and about our place in the cosmos. But let's get back to the here and now. Where are they going to put this amazing facility?
Well, they've got a few ideas. They could build a completely new SRF, maybe at a NASA center like Johnson Space Center, or, maybe they modify an existing building. They're even open to working with places that aren't run by the government, like universities.
Can you imagine a university with a Martian sample lab? That would be wild. But okay, this all has to cost a fortune, right? Building this facility, the equipment, the scientists, it all adds up. Does it say anything about how much this is all going to cost?
Yeah, it doesn't give like a specific number, but it does say, yeah, this is going to be a major investment. But it also says, hey, look at the potential return. It's not just about the science. It's about new technology.
Yeah.
Inspiring the next generation of, scientists, engineers, explorers.
So the potential benefits, they're worth the price tag. That's a big bet. But maybe the payoff could be, well, out of this world.
Yeah, exactly. It really shows our ambition as, as humans, our willingness to explore, to learn, to, push the boundaries of what we know.
It's a reminder that we're not just, stuck here on Earth. We're explorers, driven by curiosity, a thirst for knowledge. And this Mars sample return mission, it's a huge step forward on that journey.
And while we wait for those samples to get here, we can only imagine what secrets they hold, what stories they might tell us, what new chapters they'll add to, the story of human exploration.
It's a story that's been going on for, well, forever, from the first people who looked up at the stars to the scientists and engineers who are, making this mission happen. And as we wrap up our deep dive, we encourage you, our listener, to keep exploring the full PEI's document. It's out there for anyone to read. It's fascinating. So until next time, happy exploring.